Hi, I'm Matt Marshall, founder and editor-in-chief of Venturebeat. We're here live from GTC 2024, talking with Mark Lohmeyer, VP and GM of Compute and ML Infrastructure from Google Cloud. Welcome, Mark.
Thanks, it's great to be here, Matt.
So we're here at the GTC event. There's been a lot of announcements. Jensen's keynote was long, had a lot of things included. Google, what did you guys announce today with Nvidia?
Yeah, so first of all, it's great to be here, great to feel the energy, from Jensen's keynote as well as on the floor. And at Google, we are really excited to be partnering with Nvidia in so many ways to meet the needs of our joint customers together. We had some really exciting joint announcements today, literally at every level of the stack, from hardware to software to new consumption models. At the hardware level, we're really excited to announce that we're going to be enabling the Grace Blackwell 200 based hardware systems as Google Cloud services. We're really excited about the amazing new capabilities that will enable for our customers.
And Mark, just to cut, is that new, the support of the hardware, or is this just an involvement, a continuation of the support of NVIDIA's hardware?
It's a great point. So we have a very deep relationship between Google and NVIDIA over many years. We've been fortunate over that time to introduce many solutions together. At Google, we like to say that our goal is to be first invest with NVIDIA, sort of first with their new capabilities, and best in terms of the ways that we implement them for our joint customers. So we have many instances and VM families together with NVIDIA, and really this Grace Blackwell solution that we're going to be working on together is just the next step in that deep partnership over many years. So we're excited about that. But I think one of the things that's interesting about Google and the way that we work with NVIDIA is it's not just about the hardware, it's also about the software and the frameworks and the new consumption models we're enabling together with them on top of that NVIDIA hardware. And so we're also really excited to announce support for JAX, which is a leading framework for training of very large-scale models, which we developed first inside Google, but we're now enabling this together with NVIDIA, JAX support on top of NVIDIA GPUs. So we're really excited about making that available to our joint customers. And then if you go up one more layer up the stack, we enable enterprise customers around the world to basically take existing models and tune them and serve them easily with their own enterprise data. We do that through a platform called Vertex AI, and we also announced that we're going to be supporting NVIDIA GPUs within that Vertex AI platform.
Got it. Let's come back to the Vertex GPUs. Yeah. Going back to JAX, you called that out very specifically. Could you talk a little bit about why the developer community, the enterprise community should care about JAX? What are you most excited about there?
Yeah, we're super excited about this. So as I mentioned before, this really came out of Google research. And I think one of the things that is unique about Google relative maybe to some of the other hyperscalers is we are both broad and deep in terms of our AI experience and expertise over many years. And so we have a large, very sophisticated research team with Google DeepMind. That team then creates the models and the tooling around those. So Gemini is a great example of that. Gemma, which is an open source version of the same. And then we have experience taking those models and basically scaling them in production in applications that serve billions of consumers around the world. And all of that runs on top of our infrastructure, right? And so it's that sort of flywheel of expertise that we're able to bring to bear. And JAX comes out of that, right? Okay. JAX came out of the fact that, hey, what does it take to be able to train a large-scale model like Gemini, and doing that for our own purposes. But now we're really, really excited because we're making that available for external customers through our cloud services on top of NVIDIA GPUs, which are obviously broadly used in the industry. So it's these types of joint innovations where we're super excited about.
So there's a lot there. So help me break it down. You got the hardware, you got the software, you got these frameworks. JAX, what are you personally most excited about, Mark, right? When you take a step back, what are you most excited about from the NVIDIA GTC and the ecosystem you have?
I mean, I think more broadly in the industry, I think it's an incredibly exciting time. If you just look at what these models are able to do, it seems like every week, we're discovering some new, incredibly powerful, amazing use case. And, from where I sit, I'm thinking about the infrastructure and what infrastructure do we need to be building and enabling within Google and Google Cloud to enable that next generation of models. And it's those things that I talked about before, I think are going to be fundamental to enabling this next set of models, this next set of use cases. And in particular, I think one trend we're going to be seeing more of is the shift to everyone focusing more on inferencing and serving of these models. right? To date, a lot of it has been about how do you train them, and that will obviously still be extremely important going forward. But now as these models go into production in enterprise applications and consumer applications, serving of those models, inferencing, generative AI, becomes the next big problem to solve together. And I think a lot of the announcements that we made together between Google and Nvidia are going to be really impactful in terms of scaling the inferencing of those models cost effectively with sustainability and efficiency. And so I'm excited about where that's going next.
Right, Mark, thanks for that. One of the interesting ironies here, perhaps, is that LLMs have set this revolution off, and Jensen was talking very clearly about this being the generative AI era, but yet, there seems to be so much more value being created, or the appearances on the hardware side, or Nvidia's ecosystem shooting to over $2 trillion in market cap, and there's this supply and demand problem, right, where there's more demand for these GPUs than supply, partly driving that value. Just curious, do you see a change in that demand happening sometime soon, cooling off, maybe the prices coming down?
Yeah, so I mean, as you said, the demand has been tremendous, and we don't see the demand cooling down at all, right? We just see the demand continuing to increase over time. We see the diversity of models increasing, we see the use cases expanding, we see more and more customers, whether they're digital natives or enterprise customers, finding those first use cases and driving them. So we see the demand continuing to grow. From a Google and Google Cloud perspective, we're working hard to meet that demand, right? And so we've been able to deploy large amounts of capacity, serving the needs of the vast majority of our customers. But this is a never-ending process, right? That demand keeps growing. We need to keep landing more and more capacity. And so we're very, very focused on that and feel good about where we are there. Though one other thing I would add is that while landing the physical capacity is important, what's also really, really important is how do you efficiently use that capacity? And so we've been making a lot of investments, again, at that software layer, at the consumption layer, to enable our customers to most effectively and cost effectively utilize that capacity. To give you one specific example, we just recently announced something called Dynamic Workload Scheduler, which is a new consumption model designed specifically for AI workloads. And if you think about the different use cases for AI, yes, some of them are sustained use, like training over a long period of time. So for that, you might need a reserved instance, or in Google Cloud, a committed use discount, for example. But there's other use cases like fine-tuning, where you just need a certain amount of capacity for a certain period of time. You want to know that it's going to be there when you need it, but after that, you don't need it anymore, right? And so Dynamic Workload Scheduler allows our customers to do just that. Say, I want this type of GPUs in this location for this period of time. We'll guarantee it's going to be there when they need it. And then, of course, they only have to pay us when they're actually consuming it. So it's also very cost effective for our customers.
Mark, this is interesting. I think we're running out of time, but I've got to get this question. I know Google has built some of its own custom chips, right? You talk about the frameworks, JAX, you've got TensorFlow, you've got the models. How long will this dependence, I mean, you're the compute guy at Google, how long will this dependence on Nvidia last? It really feels like they have that kind of gatekeeper function on the GPU side. How long will that last?
So the way I think about it is it's all about our customers, right? Yeah. And what do they need, and how can we deliver them what they need in the most effective way possible? Yeah. And so yes, we have our own in-house TPU technology, which we're excited about, we're making available to customers, but we also find that customers like choice, they like flexibility. A lot of customers love, for very, very good reason, NVIDIA GPUs and NVIDIA technologies. And so our strategy is to make all that available to them, and as I mentioned before, with NVIDIA in particular being first and best with them, first with all their new technologies and best relative to any other hyperscaler. And I think the strategy is actually playing out quite well. So if you look, for example, at the companies that know this technology the best, it's probably the generative AI startups, right? Okay. Most sophisticated, most technologically advanced. Over 70% of those have chosen to run their workloads on Google Cloud, and a significant portion of that, of course, is on top of NVIDIA GPUs. So we just see that partnership continuing to be really fundamental. It's been deep in the past, you're going to see us deepen it going forward, but really it's all in service of our joint customers, and so we're super excited about that.
Great, last question before I let you go, Mark, is if you take a step back, what do you think are some of the biggest infrastructure trends, or maybe it's a single trend that maybe you see that maybe is underappreciated in the market right now?
Yeah, so I alluded to this a little bit earlier, but I think we are starting to see a shift from the main usage being for training and maybe tuning of these models. And while that's not going away, people are going to keep doing that and keep iterating on new versions of the models. I think we're going to really start to see inferencing take off, and how you design and architect at a systems level across hardware, compute network storage, software, the frameworks, the compilers, Kubernetes, and the consumption models, to be able to serve those models in production at scale, great reliability, great security, great performance, low cost, right? Because the profitability of many businesses will depend upon the cost to serve. I think that's the next big challenge that the industry has to come together to tackle. And we're really excited about a lot of the things that Nvidia has been talking about today, and our work with them to enable some of those use cases going forward.
Great. And is that going to happen this year?
Yeah, absolutely. I mean, we're already seeing it happening, where we're seeing customers shifting more and more of their workloads to serving, right, to meet the business needs of their customers.
Yeah. Okay, Mark, thank you very much for joining us.
Thank you too. Great to be here.
So thank you, guests, for watching, and be sure to explore more sessions in the GTC catalog.